Welcome back to my channel. In this video tutorial, we are going to focus on solving this problem you can see on the board. To solve this problem, we'll be using De Morgan's law of logic gates and some of its properties. If you haven't watched my video on De Morgan's law of logic gates, I recommend you click on the video that just popped out at the top right hand corner of this video, or if you just check out the description of this video for you to have solid and concrete knowledge about what we're discussing in this problem or in this video. So let's begin. Well, let me just give you a clue about the De Morgan's law of logic gates. This law is being split into two. The first one is when you are having complement of a product. According to the Morgans, the complements of a product can be replaced by the sum of the complement. So what does that mean? Makes sense. It means if you have like the inputs B, A, and C, and everything as a complement, then we can replace it with A complement plus B complement plus C complement. The product complement can be replaced with the sum of the complements. And at the same time, the sum of the complements can be replaced by this product of the complement. So which means this is the same as A, B, C complement. So that's just what you need to be familiar with in dealing with this problem. Now, I want you to know one more thing. When you have a certain input to have a negation ahead it, you have another one to have double negation. Now, this means the opposite of whatever the value of A is. Why this means A itself. So when a certain input is having double negation ahead it, then knows that the result is going to be nothing but that input in exact. So hopefully you grab that. So let's begin. So what we like to do in the first place is to focus on this because it seems to be more compound than this. So according to De Morgan's, when we are having the sum of complements, we can turn it to the product of complements. So therefore, this will result in x, y bar, then all complements. Okay, it covers x as well. Then multiply by, let me just use a dot product, x bar with another bar. Okay, what I did was that I've split this complement, the longer complement, that is the yellow one. Now, some of you might be wondering now, why did I start from outside and tend to be solving inward? Well, if you tend to start from inside and tend to be solving outward, we are still going to end up having the same answer. But that's just me. That's what I like using because it's quite straightforward and clear to use. You won't get stuck. I've usually used to use the other way around as well, and I've seen the difference. Even with the fact that I'm a teacher, I see sometimes get confused while solving while solving from inside to outside. So I prefer using this, and I recommend you should start and you should always use that. So let's move on. Now earlier we said when a certain input is having double over bar headed, then the result is simply that input. So I'm just going to repeat this at the left hand side. So right now it return to x plus y, then x plus y bar, then plus xy bar, then multiply by x. The bars as cancels out. Okay, perfect. So what I would like to do right now about this expression at the left hand side, I would like to expand them. So to expand them is just the normal way you expand brackets in algebra. So you just need to dispute each term relative to each term in the second parenthesis. So that should be x. But don't write x squared though. X times y bar, xy bar plus xy bar, and y times x plus xy, then y times y bar plus y bar, y bar. So right now I can split this. This is a product of complement. You can see x and y bar are multiplying each other, and ahead them we have a bar which is a negation. So I can split them using the De Morgan's law of logic gates. For the product, of complement, we can replace it with the sum of the complements, and that will be x bar plus y bar bar. The y will now be having two bars ahead it. Now, since y is now having two bars ahead it, we can replace it with simply y. So I'm having xx plus xy bar plus xy plus yy bar, then plus x bar plus y, then multiply by x. So what should I do next? What do you think? Pause the video and continue from here. So the next thing I'm gonna do is just to use some of the properties of solving problems involving Boolean algebra. So right now, what I will just do is that in input times input is simply that input. Okay, so I'm having x plus xy bar. X times y is simply xy. Okay, that's nice. Then y times y bar, that will be 0. That will be 0. Okay, I can surely show you why it is 0. If y is 1, y bar will be 0. 1 times 0 will result in 0. And if it is the other way around, if y is 0, y bar will be 1. 0 times 1 will still eventually result in 0. So a certain input multiplied by its negation or multiplied by its inverter, then it needs to know that the result will be 0. So this is adding. So I would like to distribute this as well. So that's x times x bar times x bar plus xy. So right now I can analyze that x times x bar is also going to be 0. Then I add x plus xy bar plus xy plus xy. So what I want to do next, let's see that. So the next thing we need to consider doing is to associate this together. Okay, we need to associate that together. Okay, so I'm having x plus, then let me just take x to be the common value, and I'm having y bar plus y, then plus xy. Okay, now it turns out that y bar plus y will always result in 1. If y bar is 0 and y is 1, 0 plus 1 will be 1. And if y is 0, y bar will be 1, 1 plus 0 will always be 1. So eventually, this will be x plus x times 1 and plus xy. So we're almost there, but we still have some few steps away. So right now I'm having x plus xy. So let me just compare this. Let me combine this and this together as well. So I'll be having x. So since x is common and x is common, I can take it out as the GCF. And I'm having x in the bracket of 1 plus y. A certain input plus 1 will eventually result in 1, regardless of whatever the input is. Either the input is false or the input is true. That is 0 or 1. The result will always be 1. So finally, the result should be x plus x times 1. And x plus x times 1 now will be x times x. And x plus x is simply x. And this is our final answer. And that's the solution to this problem. Hopefully you find it helpful. If you haven't subscribed, please do subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.